I said, today we are going to look at problem solving using exponential equations, okay? So for exponential equations, and we talked about, yes, it is flickering. Probably the lamp needs changing soon, okay? So exponential relations, we said that they're modeled by the exponential equation y equals a times b to the power of x. Okay? We talked about that in the grade 11, right? And we said that, do you remember a, what does a represent?
Initial.
The initial value. And what?
Starting.
So when x is equal to what? So that's when x is equal to 0, right? So when your time or your starting, the starting point. And b is, we call b the growth or decay factor. B is greater than 1. That means we have a growth, exponential growth. And if b is less than 1, we have an exponential decay. I should write exponential before, so if you haven't written this yet, write the exponential first. So exponential
Even for b, exponential
growth, yeah. And this is going to be, if b is between, I should say also this is between 0 and 1, then we say it's an exponential decay.
Just clarifying, 0 to 1 says point something.
That's right. So if it's like 0.75 or 0.5 or anything that's a 0 point something, that's an exponential decay.
It doesn't exactly represent 0. Like it cannot be exactly 0.
It's between 0 and 1. Okay? So before I go to the next example, I'm going to talk about the different equations that we use to model our exponential functions. Okay? So we have ones that we use specifically for doubling, specifically for half-life. We have ones that we use specifically when we are given a rate. Okay? So I'm going to talk about these. So you might want to grab a piece of paper to write these things. So with the doubling and half-life, so these are special case scenarios. Okay? With the doubling, I will have an equation that looks like this. Now, the equation could look a little different with different letters, but I don't care about the letters as much as I care about what do they mean. Okay, their location and what do they mean. So it will be y equals a times 2 to the power of x over d. Okay? Now, y is your final amount. Okay, so that's what you're looking for. Y is your final amount. A is still your initial. And 2 is because it's doubling. Okay? That's why we have the 2. Alright? What if it was tripling? What would you put? 3. Okay? And then x is your time stamp. Is it like if you're looking after 7 years or after 10 years or after 20 days or whatever it is, right? So that's your x. Now the important part that we're adding to this also is d, which is your doubling time. So usually in the question goes like this. You have 100 bacteria. That's your initial core, right? Right? And the bacteria count is doubling every 5 hours. Okay? So you have 100 bacteria. That's where it is. And the bacteria count is doubling every 5 hours. So here is the hint that I have to use this formula is because it says the word doubling. Okay? Because it says the word doubling, I know I need to use that part. Now, what's my initial count? 100, right? So 100 is my A value, right? Now, 100 bacteria, you have 100 bacteria, the bacteria count is doubling every 5 hours. What does that 5 hours represent? It's the D, it's your doubling time. It's how long it's taking for the bacteria to double, okay? So that 5 hour is your doubling time, and that is D, okay? So now to set up the equation goes like this. Y equals 100, 2 to the power of x over 5. That's your equation. Your equation should always have two variables, y and x, right? Now, what I can ask you to this, what I can add to this question, how many bacteria will you have after 20 hours?
Oh, then you put the 20 where the X is.
Now you're gonna replace 20 with the x, because I need to know how many bacteria you will have after 20 hours. So I can add to this question, sorry, or what bacteria can right? So in this case, I'm going to use exactly the same equation, right? But I'm going to replace x with 20 because I'm looking exactly at 20 hours how many bacteria I have. Does that make sense to you guys? Okay? So remember that the equation for doubling is y equals a bracket 2 to the power of x over d. Now, you might see in the formula sheet or on your formula something that looks like this. Or A equals A0, right? Or whatever. Right? You might see something like this. This is any different than what I have written. No. A is your final amount because that's replacing the Y. A0, that's your initial amount, that's replacing the small a, right? So it doesn't matter what letters they use, right? It's still the same. Okay? Now, what do you think it would be for half-life? What's 1/2? Like y equals 1/2?
2.
Okay. So for half-life, you will have y equals a half to the power of x over h. Now, still the same thing. Again, I'm using a different letter just because it's half-life. Still the same setup, right? Where a is your initial amount, y is your final amount, half is because it's half-life, and h is your half-life time. Again, it will be like the degradation of carbon-14 takes, the half-life of carbon-14 is 10 years, right? You start with 500 grams. Set up the equation, right? So 10 is your half-life time for carbon-13. So 10 is going to replace the half-life, the H, okay? So just watch out for these words when it says the half-life time, okay? Are we okay with this? All right. So these equations, we use them with the special cases of doubling and half-life, okay? Now, we look at other equations when we have a rate, okay? So when I say, let's say I put $500 in the account and the interest earned is 4%, okay? So I'm giving you a percentage here, okay? So we have different types of equations for these ones. And these equations are, anyone remember? 1 plus I to the power of x. That's for exponential growth.
Decay is going to be 1 minus I.
That's right. So these formulas, sorry, minus. These formulas are used when I have a rate, when I have a percentage, where R is your rate in decimal. Where I is your rate in decimal, okay? So these are used when you are given a percentage, right? And I is your rate in decimal. Right? So my 4% is 0.04, and that's going to replace the I. How about the A? What's the A again?
Initial.
A. Are we okay with this? So these are the formulas that we usually use. Okay? Let's look at this example. So a city's population can be modeled by the equation P equals 1.4 times 1.0415 to the power of T, where P represents the population in millions, T years after 1985. So what's my initial year?
85.
1985. What was my initial population in 1985?
3 million. No. Oh, wait.
What's my initial population?
1.4 million.
1.4 million. How do I know that my initial population is 1.4?
That's the initial value.
That's the A value, right? So if you look at this equation looks like this. This equation looks Y equals A, B to the power of X, right? Where A is my initial value, so that's 1.4 million. Do you guys have any questions about this part? So the beginning population is 1.4 million. Now the question goes like this. In which year did the population first exceed 3 million? So what's my final population that I'm interested in? 3 million. Now just so we can look at this, is this an exponential growth or exponential decay? Growth. And how do you know that? That's right, but how do you know from the equation? The base is greater than 1. You see that base? It's greater than 1. Okay? So population is growing at a rate of. So let's find the population growing rate. Okay? Because it's a growing rate, so it's going to be 1 plus I, right? And 1 plus I is going to equal to the 1.0415. How can I find my rate? What do I do? So remember that my equation is Y equals A1 plus I to the power of X. Okay? Eyes on me for a second. I know that the 1 plus I is equal to 1.0415, correct? Okay. So how can I solve for I? What do I need to do? Isolate. How do I do that?
Bring the 1 over.
Bring the 1 over, it becomes a
Minus.
subtraction. And then subtract 1. So my I is 0.0415. What is that in percentage? rate, my rate is 4.515%.
So it's an exponential growth if it's larger than 1?
Correct. And then if you look in that bracket, it is larger than 1.
Oh, I was wrong.
All right, now, what is given to me again? So let's go back here. They gave me that. They want to know which year did the population first exceed 3 million? So what am I looking for? What do I know?
You know that you're starting off at 1.4 million,
Mhm.
and it's a growth, so you have to input the proper time period to exceed 3 million.
To get,
The first exceeded 3 million.
okay, so where would I, so that 3 million, where does it go in my equation?
The initial.
P, right? So that 3 million is my population, and that's going to replace P. So I have P equals 1.4 times 1.0415 to the power of T. I know that my final population is 3 million. So I just have to put it for P. Now, how can you solve for T? What's the first thing you want to do? Sorry? Yes. First of all, you want to isolate as much as possible. So you want to move the 1.4 over, and then you want to divide 3 by 1.4. So what is that? What's 3 divided by 1.4? 2.14? Okay. All right. Now, do I know any way to solve for T? Because T is in the exponent, remember. Have we learned any way to solve for an exponent?
The base should be equal.
Let me go back.
And because this is a decimal, it's going to be hard. So if it was, yes, so you're right. If it was like something like where I have 16 and I have 2 to the power of t, that's easy because I can make my bases the same and I can do 2 to the power of 4 equals 2 to the power of t and then drop the bases, right? That's what we learned yesterday, right? So that's easy if it's not a decimal. But what if it is a decimal? Have we learned anything? No. So we're going to start with guess and check first. And I'm going to teach you a way that's not in the curriculum for the grade 12C, but it's an easier way, right? It's a faster way. I'll teach it to you in the next page, okay? But I won't expect you to, you can always use guess and check, okay? But if you want to use the second way, feel free to do it, okay? So guess and check is the way for you guys.
But that's so much work, probably.
It is so much work. That's why we do. That's why I teach you the other way. Okay, so give me a value for t that you would like to start with, and don't say the answer because I know that you were trying on the calculator.
Did I
Don't say
get
the
it,
answer.
though?
I think so. Yes. So don't say the answer. Okay. Give me a number that you would like to start with for t. Yep.
3.
3. So let's do 3. And so if I do 3, what do I get? What do you get?
Does it have to be in brackets?
Doesn't.
The power of 3?
Yeah.
1.1493.
And is that anything close to 2.14? Because my final answer, it should be like close to 2.14.
No.
No, so that's not it. Okay, give me another one.
5.
5. Do it. Say it and like use the calculator.
1 sec.
18?
No, not that.
Oh, okay. What's 1 point
No,
what?
that's nowhere close.
What is it?
Oh, no, I didn't give it.
Press answer equal.
0.15 to the power of 5.
Yeah.
1.2251.
Okay, that's not it. Okay, give me more.
12.
12. Okay, so I'll do 18 next, okay? 12. What? 1 point what?
6.
6,
8,
2, 8, 9. Okay, it's not it. So 18?
Closest is 19, but goes higher.
Okay, so what's 18? 2.07. So that's close. Okay, close. Let's try 19.
Goes higher.
What is it?
It's 2.7.
2.7? 17? Okay, a little higher, right? So it's somewhere between 18 and 19 years.
18.
16? Sorry, 15, 16, I can't.
2.16.
16. So, in order for it to reach that 3 million, it's going to take about between 18 and 19 years. Okay, somewhere between the 18 and 19 years. So we're going to say 19 because we're looking at exceeding 3 million, right? So about 19 years. So anytime you're looking for the exponent, you're going to have to follow this method where you isolate as much as possible for the base, and then you're going to do guess and check to find your answer. Now, you're not going to get it from the first time, you're not going to get it from the second time, third time, fourth time, maybe the fifth time. It was a teamwork today, and we got it. Okay? And that was not too long, actually, right? It is. Now,
So the answer can be higher.
sorry?
The answer can be higher.
It's about, because it says exceed 3 million, right? That's why I went with a higher number,
But
because
if it doesn't say exceed, then
then
it has to be
it has to be lower, yeah. And it's in between, right? It's somewhere in between. You can go like in between, actually. So I've already talked to you guys about this, right? So you see now the formula is using A and A0, right? Instead of Y and A. Doesn't matter how the formula is written, okay? What we wrote Y equals to A, right? 2T over D, we wrote X over D, I think, right? It doesn't matter what letters you use. Probably on your test, I'm gonna give you this formula, because that's what's in your notes. So as long as you know, it's the same. And we said that D is the doubling time. And H is the half-life time. So, here is your lovely attention here for a second? So when I have y equals a to the power of x and I'm looking for x, I can take the log of both sides. So I can do log of y equals to log of a to the power of x. Okay? So when I do the log of both sides, the log forces the exponent to come down as a multiplication. So when I take the log of both sides, it forces this exponent to come down as a multiplication, and that becomes x times log of a. Okay? So that becomes like this. So log of y equals to x multiplied by the log of a. Now, because it's a multiplication, I can bring the log of a over, and that becomes a division. Okay? And then now I can use the calculator to find the answer. Okay? So let's look how that's going to work. So I have 5 equals 1.06 to the power of x. You can do guess and check from now until I don't know when to find the answer, especially if I want the exact answer. But if you want to use the log, right, because I'm looking for the exponent, you only use the log when you're solving for the exponent. So I take the log of both sides. So I write log 5 equals log of 1.06 to the power of x. Are we okay with this step? Now, the log forces the x to come down. So that becomes x times log of 1.06. So I have log of 5 equals to x times the log of 1.06. Now, because it's a multiplication, I can simply move the log of 1.06 over, and that becomes a division. Now, on your calculator, can you do log of 5? Make sure you close your bracket after it opens the bracket. I don't know, when you press log.
Log that bracket or
So,
the bracket?
It puts a bracket.
For her, it
on
puts a bracket. For you,
27.6.
okay, open bracket 5. No, after.
It's 27.12.
Bracket, yeah, divided by. No. So you use the regular log for this one. Yeah. The other one gives you different bases. In this case, we're not doing it. Okay. So what do you get for that?
27.6.
Good. So you could have actually done the guess and check. It took you about
A million years.
a long time to find the exact answer. Okay. Now if I come here and I plug in 27.6, so I go 1.06 to the power of 27.6, you should get something that's very, very close to 5. Right? 4.99. Yeah. All right. What would you like me to do for the next question?
Log.
Log both sides because I'm looking for the exponent. Guys, please don't do it for any other reason, okay? Just we do that for when we're looking for the exponent. We only take the log when we're looking for it.
Is there ever going to be a time where you'll have to do other steps before you use a log button? Like if you
Yes,
have
so
like,
if I had the previous question where 3 equals 1.4 times 1.0415 to the power of x, right? First
you
I
have
always
to bring that over.
bring that over first, then you can
Find
do
the answer and then log both sides? Okay.
Okay, what do I have to do for this one?
Log both sides.
Log both sides. Okay, divide by log 0.97, but remember here, I have 2x equals 2, okay? Remember here, I have 2x is equal to that. What would be your answer for that? What would be the log of 25 divided by the log 0.97?
Negative 105.7.
Negative 100.
5.7.
105.7.
Yeah. 0.67.
Okay. Now, what would be my final answer here? What do I have to do?
Divide by 2.
Divide everything by 2, right? So that would give you negative 52.8. And that would be your final answer. You can double check your answer. You can put negative 52.8 on the x and replace it by the x and check if that's correct. Okay? So here's what I want you to do. I want you to try the next question.